So local linearity is all about approximating a y value of some point using a point that's nearby. So problem number one is asking us, or telling us that the function f is twice differentiable, so that's just some fun information. They give us a bunch of points and slopes, and it says, what is the value of the approximation of f of 1.9 using the line tangent to the graph at x equals 2. So they're telling us which line to use. That's the tangent line. And our goal is to approximate the y value when x is 1.9. Because we don't actually know anything that's happening at 1.9, we have to approximate it. So since x equals 2 is close to 1.9, we're allowed to use its tangent line to help us out. So the tangent line at the graph of x equals 2 is going to be y minus y1, think point slope formula. I'll write that up top for us. So point slope formula is here. So our tangent line for x equals 2 is going to be y minus 1, because that's the y value there. The slope at x equals 2 is 4, because they gave us f prime of 2. And we have x minus 2 because of the f of 2 equals 1. So this is our tangent line at x equals 2. We're going to use this to approximate what's happening at 1.9. So all we need to do is plug in 1.9 for x and solve for our y value. So we can go ahead and add 1. And then simplify this here. And a lot of times we won't get a calculator on this part of the exam. So we'll have negative 0.1 times 4 is going to give us negative 0.4 plus 1, which gives us 0.6. So our answer is going to be B for this one. All right, question number 2 says for the function f prime of x equals 2x plus 1. So this is our derivative, and then they give us f of 1 equals 4. It says, what is the approximation? So again, we are going to approximate for 1.2 by using the line tangent at x equals 1. So the tangent line for x equals 1 is going to be y minus 4, because 4 is our y value here, equals the slope we don't yet have, so I'm going to leave that blank, times x minus 1 because of the x value given. So the slope at x equals 1, we're going to need to use our derivative equation, which they gave us here. And what we want is to do f prime of 1, because we're, again, using the line tangent at x equals 1. So I'm going to plug in 1. We get 2 plus 1 equals 3. So our slope here is 3. And now what we can do with this is use this tangent line to approximate for f of 1.2. So we're plugging in 1.2 in for x. We'll get 0.2 on the right times 3 gives us 0.6. And then if we add the 4, 4.6 is the y value for this approximation. All right, moving on to problem 3. It says selected values of the derivative of the function g are given. So there's our derivative table. It is known that g of 3 equals 17, and we want to approximate g of 3.2 using the line tangent at x equals 3. So let's first start by writing that tangent line. So y minus 17 equals the slope at x equals 3. So we need the derivative at x equals 3. That's going to be negative 1.2 times x minus 3. So here's our tangent line. And now what we want to do is plug in 3.2 in for x. And then let's simplify. So 3.2 minus 3 is 0.2. Ugh, these are some ugly numbers. Negative 1.2 times 0.2 is going to be negative 0.24 plus 17 means y equals 16.76. Is that an option? All right. All right, question number 4. The function is twice differentiable. They're giving us a couple of values. F of 2 is 1, f prime of 2 is 3. We want to approximate f of 1.9 using the line tangent at x equals 2. So let's start with our tangent line at x equals 2. So we will have y minus 1, so we're using the x and y, 2 and 1, equals the slope when x equals 2 is 3 times x minus 2. So for the tangent line, we need the point and we need the slope. Then we use this tangent line to approximate another value. And so for that piece, we're just plugging in 1.9, and then we will simplify and get our y value. This last problem is actually the exact same as number 3, so you are all done.